Hey there. The breadcrumbs are at the top. Subject matters below. I'm going to drag you guys into my world. Today's world, where I live and the shit I do to make money. Alright? Subject, caliper boot, undersize, Mayday. What does Mayday say to you? It says, help, pal. Let me show you something. This is a vintage boot, meaning boots for an older car. The boot, as you can see on the left, is what they call a hard boot in the industry. A hard boot has a metal OD and it presses into a bore. A soft boot is all rubber, all right? Anyways, let's get that out of the way. See this hard boot here on the left? It presses into the bore in this caliper. It's a 4-piston caliper. I'm showing it. One way is up and one way is down. It's upside down. See it? This one here is up and that way is down. Here's a cross section of the boot. I cut out a section here, and that little black outline there, that shows you the metal. All right? Are you getting my drift? All right? I'm gonna lay some shit on you. Hang on. All right, I'm gonna take you to my CAD system. I'm gonna show you that boot. All right. First of all, this is a top view of the boot. It shows the identification on it. The part number VB4. What's that? Vintage boot number 4. That AGR manufacturer's code. That's the cavity number, and that's the company identification, Acushnet Tool Company. I'm going back now. I'm going back to 2003. We still do this. You see that? That's a cross section of this view here. See, it's a cross section. The hash marks or cross section marks are showing you that's all rubber. This is showing you it's steel. Let me get down to where I'm working. My objective is, well, let me get you down here. I'll start with my bullshit down there. It's my scribble sheet. I scribble all over the place. Let me start here. I'm showing the boot upside down. The problem, you see where the mouse is? That diameter from there to there is 10,000ths of an inch too small. We got a lot of them in stock. Somehow it got buyers, and we got quite a few in stock and customers that want the product. It's an easy fix. Build the new die and stamp some new ones. Problem, the time involved to do it, to get it done. In the meantime, customers are not too eager to wait. So what I gotta do is make these bigger by 10,000ths, and I'm golden until a die can be built. You see that? Okay? How am I gonna do that? Let me show you. Alright, let me just do this. You see 2 parts here, one above the other. You see a milling machine table here. See it here? It says milling machine table, T-nut. These are all round parts. They're made of stress-proof, 1144. You can see this one and this one. There's only 2 metal parts here. That's a 1/2" 20 socketed cap. I mean, yeah, it's not, I don't know. It's a 1/2" socketed cap screw. All right. I'm showing you that. Now this can come apart. You can see this piece here can lift off, right? Right now, that piece and that screw are pulling all down on the table, so it's secured to the table. All right? Let me show you the piece above it. Obviously, stress-proof 1144. All right? It's a match for the bottom. Same material. Why? Low carbon, good machining, tough material. Perfect material for this job, all right? How am I? Now, here's what I gotta do here. See it? Here's a cross section of the part. on one side only. I gotta take this metal, this is metal, this empty place, and I gotta bend it out this way by 5 thousandths. Can it be at an angle? Absolutely. Alright? Not a problem at all. Matter of fact, I prefer it at an angle. So how do I bend it? Right? How do I bend this out this way? Alright? Well, what I've done is I've contained it, you can see it here, in this metal, and I'm going to push it this way at an angle. Let me show you how I plan to do it. Maybe you guys got a better idea, but I'll show you. Alright? As you can see that's an angle, that's 45 degrees right there. Obviously, the other side is 45 degrees there. You know, it's symmetrical. All right? You see it? And it's just touching here, but you notice there's a gap here. See the gap above this piece? That figures into be, you know, that's part of the picture here. I'm going to show you what I plan to do. Let me go back. Now I'm going to show you. I'm going to come down when it comes down this way. Oh, by the way, you see this red? This diameter, this ID, just fits over that OD, holds everything in line. We use the term register. Lines it up anyways. Let me do this. I'm gonna drop it down some and show you a little bit of the action here. Oh shit, hang on. I do that a lot. Now I'm gonna push down 10 thousandths. See it? 10 thousandths, 10 thousandths. Obviously this rubber's gonna go this way and everything's gonna tend to go that way, right? I don't think it's gonna take a hell of a lot to do it, you know. But anyways, that's my plan, okay? Well, let me show you this now. Let me get this out of the way. Now, here's what I'm saying. You see this? The top of this, which is above. Let me do this. You see the head of the cap screw is quite a bit of ways from the top of that surface. I can take some off of that surface and not affect the socketed cap screw. Let me bring this down to where it just touches. See that this is touching there, right? And you can see that this angle is just into that rubber by a little bit, right? Obviously, I'm going to push down. If it doesn't move, I'm going to remove it. Take this piece out. See this piece here? Take it out, face a little bit off, put it back in. I may have to do it multiple times, but once I get that out 5 thousandths, it's fixed, no problem. All I have to do is push down to the stop. How do I do that? Now, this is a logistical nightmare. How do I load it and unload it? Let me lay it on you. All right, you see this? That's the handle. It's 1.25 inches diameter, and it's tall, so a guy can hold it in his hands, have the top sticking above his hands, so he can just hold it. And then what he does is he drops it on here. It's guided in by this OD, and he gives it a fucking whack with the hammer. It hits the stop. He lifts it up. Only takes a couple of seconds, right? Now the guy that's doing the other parts, two-man operation, the other guy's got to take this out. See this? It's got to be removed. You know, is it easier to take out? I don't think so. That's never been so very little. So here's what I got in mind. I'm going to drill one hole, as you can see, and a vertical hole, as you can see. And I'm going to make an annular groove. See that radius? That's a groove all around. Let me take you to this side. It goes all the way to this side. You see it? So it's circular around the pot. So when the guy lifts it off and everything's out of the way, we take an air hose with a rubber tip, put it in there, poof! Hopefully this sucker blows all off. There's nothing here to hang it up. See, we got clearances everywhere. Takes it off, puts the other piece in. Guy's got it in his hands. Kapunk, it's over. All right? To me, that's the most cost-effective way for these circumstances. Can I make this automated? Absolutely. Will it cost me a fortune? Absolutely. This makes good sense to me. But will it work? How the Christ do I know? Most likely will work. But what I'm saying is, if somebody's got a different idea, right, I welcome it, you know? Anyways, so any of you guys out there got an idea for me, lay it on me. I'll kiss your ass on a super highway. Typical message. Let's not attack each other. Let's live and let live. Pay it forward, right? You know the routine. All right? Hang on. Like I always say, thanks for watching, and if you got a better idea, please lay it on me. This is real. I'm not bullshitting anybody. Thanks a lot.